Now I don't see from the beginning.
I can see it on your screen,
Oh,
the
from current
slideshow.
slide. Oh, there's way at the left there. Okay.
Yeah, all the way over.
Okay. Gotcha. All righty.
Perfect. All right. So we are right at 10 o'clock. So good morning, everyone, and welcome to our September Extension Master Gardener webinar. Before we get started, please do make sure that your microphone is muted throughout the webinar so that we can hear Joel speak. If you do have questions at any time during the presentation, please just go ahead and type those into the chat box. And then at the end of the presentation, we'll get to as many of those as we can. So now I would like to welcome our speaker, Joel Koci. Joel is an extension specialist in natural resource management and urban forestry at Virginia State University. Welcome, Joel. Thanks for joining us this morning.
Well, thank you. Thanks again for having me. I appreciate it because I get to speak about something that I love talking about is trees and the urban forest. And once again, I thank all the participants and also Miss Reed for making this happen. I'm a little bit about myself. I'm a board certified arborist. My certification number is 19, so I've been certified for a while. And I'm also tree risk assessment qualified through International Society of Arborists. And before I joined the Extension Service at Virginia State, I was self-employed as a commercial arborist with my own business in Central Virginia. And my contact information is at the base of the first slide there. And this oak that you see here with me up in it a year or two back is called the Eisenhower oak. It's in Goochland County, and it's called the Eisenhower oak because President Eisenhower came to Goochland County for some reason. I've never found out why. But near this tree here is a huge, almost a lake, but a huge pond, spring fed also, which is unusual. And he fished for bass in that pond when he came to visit Goochland County. Consequently, they called this oak the Eisenhower oak. And um, now, an introduction, and this is a disclaimer because this presentation is for raising awareness of the procedure for tree risk assessment and also what to do with tree risk assessment when you are doing it, how to do it, and what to do with it after you make it. Because there's two parts to tree risk assessment. One is the assessing, that is taking a look at the tree, and I'm getting a little bit ahead of myself here, but it's taking a look at the tree and see what parts or the whole could be subject to failure during normal loading. Okay. The other half of the procedure is the owner has the responsibility to deal with your assessment or your recommendations. Okay. Now, the reason why we do this is to prevent property damage, bodily injury, and tree conflicts. The tree conflicts are anything that the tree does that inhibits or prevents the normal human activity. One very, very common one is low-hanging limbs over stop signs, road signs, because it makes it hard for people to see the traffic patterns and also yield or stop at a given traffic sign. And one pet peeve that I have in our area here is all the tree limbs are hanging over road names that are on poles. So consequently, when you go to try to read the sign of the road name, you can't see it because of the tree limbs. And that that's a pet peeve of mine. And it happens almost every other corner in this area. So that's a conflict that interferes with human activity. Now, the components of assessment is determine the stability of the whole or the parts of the whole plant, okay? The whole would be uprooting, and it can be from weakened roots by construction activity, constant application of herbicides in a lawn area or herbicides in bed areas that kill out roots, and we'll talk about that in more detail shortly. And resulting assessment is given to the owner, okay? And it is their responsibility then to act on it. Now, as master gardeners, you may or may not, probably will not be qualified by ISA because it's an expensive process. I think it's $600 to take the course and then to take the test. But it's a 2-day rigorous course that you take along with the study material that you pay for, and then you become tree risk assessment qualified through ISA. Now, the assessment training is very thorough and conducted by 2 or 3 people that are the primary instructors, and it's classroom for a day and a half, and then it's field work for the half a day, and then the test. And the test is a field test also. And the assessment that the assessor, be it in your case, we'll say the master gardener can make recommendations. We'll say you need to have this part of the tree looked at or the root system looked at, and you need to have a qualified, a qualified person look at the overall tree. And then it's up to the owner to take action. And the action can be mitigation, such as pruning, cabling, rotting, or removal, okay? And a lot of people go with zero action. Just let it go, let it happen, so to speak. And it's very important that we keep these 3 phrases in mind, because when we deal with woody plants from the very onset, we've been taught incorrectly about woody plants dating back to grammar school. We have been taught that plants heal. Okay, they do not. They compartmentalize and they seal. Trees grow from the outside, outside, outside. A 10-year-old plant is 10 trees, one on top of the other. 10 woody plants, azalea, rhododendron, they all grow from the outside with the cambium layer, and also gain in height with the meristematic tissue in the aerial part of the plant, and at the zone of elongation for the root system. Okay, those are the 3 meristematic, 3 growing points. No other growing points. Those are the 3. Those would dictate the plant growth, okay, in those directions. Girth-wise, aerial growth and subterranean growth with the root system. If plants healed, we wouldn't have hollow trees, okay? And we wouldn't have lifelong imperfections on limbs or trunks and so on, okay? Another phrase that we need to not use or correct when we hear other people say it, we need to feed the plant. I bring this up because being a commercial arborist and hearing people on the radio and hearing people in nurseries and also customers say, well, this plant needs feeding, because I should rephrase that, non-plant people have been bombarded with the term feed the plant, feed the lawn, feed the plant through marketing programs from the turf industry and also from the fertilizer industry. The application of fertilizers is the deposit of minerals that may or may not be beneficial to the plant. And if I'm beating a dead horse here, please forgive me, but these are points that I think are important, that we need to change our way of thinking when we deal with the public and also deal with the plants. Photosynthesis is the only food producing mechanism through green tissue that creates food for the plant, and those sugars created through photosynthesis is what drives the machine. Okay, and there's 5 fates of the photosynthesis. There is growth, there is defense, there is propagation, which is flowering and fruit or seed production, and defense. I hope I said 5. uh, and the final phrase that we need to dispel from our vocabulary regarding plants is no such thing as feeder roots. There's 3 types of roots that woody plants have. They have anchor roots, connective conductive roots, and absorptive roots. Again, the term feeder roots denotes an ingestion of food, whereas the roots are actually ingesting water and minerals, and also in some cases with proper soil structure, enzymes from the symbiotic relationships with the soil funguses and bacteria in the soil. Okay. I hope this isn't beating a dead horse for y'all, but hopefully you'll see the reason behind bringing these terms up. Okay. These are guidelines and parameters for tree assessment, risk assessment. Okay. This is for the risk assessment is for normal loading. Normal loading is defined. And I need to make a clarification here where that we arborists now are using legal and insurance terms when it comes to risk assessment. Years ago, ending about 5 years ago, we had parameters that were given for the target and also the size of the plant. If a tree was over 30 inches in size, it self-condemned itself, which is not really a realistic situation. Just by the parameters that we had up until a few years ago, any large tree was considered hazard. Also, the location of the tree, one near a school would be considered a hazard because of the potential risk. And the risk is defined as a potential or the possibility of an event happening and then the consequences of that event. Okay, and hopefully I'll clarify that in just a minute. Now, weather conditions for normal loading, those are weather conditions that happen, we'll say normal thunderstorms that happen 2 or 3 times per year. That is a normal weather condition. The trees in your area, be it on the coast, in the mountains, or where I'm at in Central Virginia, normally trees are built to withstand winds up to 60 miles per hour. Winds over that, even man-made structures, will fail, and trees are not necessarily able to withstand winds over 60 miles per hour. That is the 60 miles per hour by the nautical definition is the beginning of a gale, and trees generally do not withstand those winds. However, it doesn't mean that they will fail. It's just that the likelihood is increased of failure over 60 miles per hour. And it's a good timing, well, not it's coincidence now with Sally coming out of the Gulf. The winds there were over 100 miles per hour. Even man-made structures are failing at that force. Another normal condition is generally an ice load of a 1/4 inch or less is considered normal icing. Over a 1/4 inch, tree limbs are more likely to fail, or whole trees are likely to fail with that amount of ice over a 1/4 inch. Then the other component is the target. What structure or situation or who bodily injury will be damaged if it falls or fails. Not the whole, but even parts, because you have to consider the tree as there's three organs in a tree. One organ is the root system, the second is the trunk and the major scaffold limbs, and then the foliage. Those are the three organs that make up a woody plant. And if part of the woody plant was to fail, what is the target? What is the potential for bodily injury? And then the consequence, would it be devastating type of consequence, a nominal type of consequence, and so on? There are parameters that we use with the matrix for the type of damage and the type of the consequence that the failure would cause. Okay, guideline. Okay, what I hope to do with this is to show you some symptoms, which is the plant's response to a problem and potential problem. Okay, what to look for? Look for the symptoms. That is, the symptom is a response of the living organism to the not just the insect or the disease, but the damage, the mechanical injury that was created on the plant. The symptom is the response to that injury. Because plants don't heal, they seal and compartmentalize. These symptoms are readily observable and seen and can be determined to be a high risk or low risk. And again, risk is the likelihood of failure and resulting consequence. Okay. Early and good tree management and maintenance begins at plant planning, early planning, not planting, but planning, and early plant selection for the site and early care is prevention of risk. It is so important that early stages of the plant's initial installation and early maintenance be of the highest quality to assure the reduction of risk and the reduction of failure because of proper early maintenance. Okay. Always keep in mind that woody plants are living, growing entities, okay? Growing girth-wise. Each year, the aerial foliage, surface area of foliage needs to grow enough and photosynthesize enough to perpetuate the strength of the trunk and the scaffold branches, and also has to grow enough to satisfy the roots requirements with sugars for their functions of growth and assimilation of water and minerals from the soil. So each year, and if you envision a teeter-totter with the ground line being the center of the fulcrum, and one end you have the roots on the teeter-totter, the other end you have the aerial part. Each year in the growing season, the aerial part outgrows the root system, but then in late summer, the sugars manufactured through photosynthesis are sent to the root system, causing the teeter-totter then to go in a different direction. It causes the root system to be larger in size and weight, and then it raises the aerial part of the plant up higher on the teeter-totter. And it's an oscillating equilibrium, oscillating. Each season there is a change in size and growth of the roots, of the organs. And when the roots outgrow the aerial part, they are down at the ground level on the teeter-totter. And when the aerial part grows in the spring and summer, it goes down at the ground level. So it's an oscillating equilibrium that keeps the plant alive. If the teeter-totter goes at a horizontal configuration and doesn't move, the plant is actually dead because you're not having growth at either of those major organs, of those two organs, roots or the aerial part. Okay, so Keep in mind that woody plants are always growing. Somewhere within it, it is growing and assimilating nutrients and sugars and translocating them throughout the plant. Okay. This is the Algernon oak. It's at Fort Monroe in Hampton, Virginia. It is now it's part of the National Park Service. We are working on the tree because you can see a little bit of dieback in the very top and also the left quadrant about 10 o'clock high there, 11 to 10. That's probably root stress and root death causing that dieback in the plant. This is the start of a visual tree inspection. By that dieback in the periphery, you can be assured that there is some root death there for some reason. And that's probably what is causing the decline in the very top and also there at 10 o'clock high. But this tree here, the configuration of this live oak is unbelievable. And this is the state champ of live oak also there at Fort Monroe. The forked trunks of this tree do not pose a problem. If this was a maple, it would have separated because of the wood strength difference between a live oak and the maple. The live oak configuration, this is one of the densest, one of the heaviest woods that we have in our area and one of the strongest. This wood was really used extensively for naval stores in the colonial times. And this tree, being at Fort Monroe, it's an interesting, long-lived, it's supposed to be over 500 years old. It is a, it was in the, pardon me, in the NPR TV show that talked about 1,000 rivers to cross. Being at Fort Monroe, which was Union held during the Civil War, this tree was used as a classroom to teach slaves how to read and write when they were in Fort Monroe. And they were at Fort Monroe because it was Union held and they were able to gain access to the area and then not be persecuted by the Confederates. This is a fascinating live oak, and it's one of many live oaks on Fort Monroe property. This tree is in the Nancy Hugo book of Remarkable Trees of Virginia. You can see the kids there when they were measuring the tree for the state champ designation. Now, early defects. When I mentioned that it's very important at time of installation and planning that the tree be handled in a way that it doesn't create more problems down the road. The slide on the left shows a defect that was created by improper loading, improper handling at time of installation or harvesting from the nursery. It was wounded, and that defect is going to be with the tree for its entire life. The tree may grow around it and create what's called reaction wood. That's reaction wood is the type of wood that is laid down the season following a wound, trying to encapsulate the wound. But it's always going to have that hollow, and rot is inside that maple. That's a red maple. It's a bottom ground tree. It's a soft wood, and the rot is going to continue for the life of that tree, causing a weak area. And also you can see the roots that are coming up because that's, I term this a plunger type of planting, where they put the excavated soil on top of the ball because they didn't want to haul it away. And you can see the rootlets that are coming up, the absorbing roots that are coming up to the surface to gain water and nutrients and air, because roots grow where there's available air and water. Okay, they don't grow. For 95% of the tree roots do not grow in standing water, and they do not grow without water at the same time. And the soil was placed up on top of the root ball because it's easier to do that than it is to remove the soil and haul it off. The other slide on the right is a fruit tree that was in a container, and you can see the bruising along the stem. That bruising happened because of how it was loaded or handled in the early spring when the bark is slipping, because of the amount of moisture under between the bark and the wood is excessive, and the slippage is from the current expanding of the cambium, causing a soft area and a bruising potential. You have to be careful in the early spring, especially with fruit trees when you're being handled or loaded. And the way these trees are handled in nurseries is it's handled for expedience and for time reasons. It's not handled for the health of the plant. It's handled so they can get the job done, get it loaded, get the truck unloaded, and then have someone buy it. I bought this from my orchard. This tree was purchased spring of 2019. Summer of 2019, it broke because of rot that originated at the time of handling and didn't show itself until 6-8 months later. And again, keeping in mind that each year, as the aerial part of the tree grows, and in both these slides, the aerial lever gets higher, creating more torque on the damaged area, which acts as a fulcrum. Consequently, you've got to be very careful that there's no damage down low, because each year the stress put on that damaged area is increasing by the length of the lever. Okay. Now, this the plunger, meaning a plumber's helper type of a plunger, planting on the left, and the slide on the right shows what happens when the soil that was deposited on the root system is washed away. This slide on the right was taken after a gully washer of a rainstorm that washed that soil away, and there is the secondary root system that tree is putting out, because the plunger type of planting chokes out the original root system that was on that plant. Because of the deposited soil, there's lack of air there. Lack of air, you don't have respiration. Okay, you have fermentation and root death because of lack of air. This tree then, by its ability to differentiate cells, puts out a different root system, a higher, it's called a secondary, it could even be a third root system that it puts out. These roots, these small absorbing roots that are coming out of the trunk right now can turn into girdling roots, and you'll see in just a second. But this right here is normal, proper root configuration from the wild. These are native woodland trees that were built, that had houses built near them, but this is how the roots do in a native, natural situation. Oh goodness, let me go. This is how those fibrous root system from that plunger planting can turn into girdling roots, as this on the left-hand side there, they're above ground. The right-hand side is girdling roots below the soil line. Whenever you see a tree trunk going into the ground without the anchor, without the flare roots, the tree should have root systems that resemble an elephant's foot when it steps down. It spreads out to take the weight and to take the forces above it. These flare roots here actually they're called anchor roots, flare roots. They actually act as a flying buttress on a Gothic building because of its configuration and how it goes up the collar just a little bit. For this tree to be uprooted, it really needs to be raised a little and then gone over because of these buttress roots. Okay. Girdling roots, okay. This slide on the right, here is the whole tree. This is the whole tree. The lady called up, said that she did some research with the internet. She said, I have verticillium wilt on my redbud. Redbuds are very, very susceptible to verticillium wilt, which is a soil-borne disorder. It is, according to agronomist, it is, and soil pathologist, it's in every inch of soil, waiting for a tree to become stressed or a plant to become stressed. Verticillium wilt affects about 200 genera of plants. However, on a redbud, it affects 1/2 of the year of the tree the first year. The second year, it gets the other half. But this is the result of girdling roots. The entire tree has been choked off. The aerial part of the tree has been choked off from getting nutrients and water to the top. Okay. Again, this is the girdling root of that redbud. Oh, let me back up and say, here there is no tree risk assessment because there's no target. Okay. You'll see in a couple minutes some trees with targets, but there's no target here. This is just to show how the correlation between healthy roots, unhealthy roots can cause unhealthy and healthy tops. Okay. Structurally, okay. This is the redbud with the girdling root on the left. You can see that split. All redbuds split. They do. That's just their growth. That's a codominant formation. I'm sure you guys have all learned about that in your biology. The right, though, on the maple on the right, that is the fork that is splitting. The diagonal fork is going over a major, not a major thoroughfare, a secondary road that has traffic on the road about every 3 minutes. There are 2 or 3 cars that are underneath that limb that is separating. That's on the maple. That maple either should have, at time of planting, when it was young, like at the stage of the redbud on the left-hand side here, that smaller limb going over the roadway, that could have been pruned off or sublimated, meaning that you reduce the aerial growth of that limb, and the taller one will sublimate the shorter one and outgrow it because of reduced sun on the one that was pruned back a little, not drastically, but pruned back some. This fork here is still going on. It's been that way for about 3 or 4 years, and each year the lever of that splitting limb is getting longer and longer, and it could be this year with the rains and also the winds that we'll be experiencing today in this area, that limb could go. And the grounds people should have told the folks that owned the property about that, but nothing at all has been done. I mentioned it to the attendant at one of the gas at the gas station, but nothing's been done about it. And this is a case that is totally preventable. Okay. Now, the slide on the left, this is what's on a property. Don't get right up next to the tree to start with. Stay away from the tree. And you want to look at the whole periphery when you're doing a tree risk evaluation or a visual tree inspection. You get away so you can see the entire periphery. And when you get dieback, such as was in the Algernon oak, from 10 o'clock to 2 o'clock high on the clock system, if you get dieback and you see poorer growth, we'll say, and dieback, dead twigs and whatnot, you know that you have a root situation that is impeding the pull of the nutrients and the water to the extremities of the tree, because from 10 o'clock to 2 o'clock is the furthest area from the root system and the first to show adverse root situation. Now that's on a biological setting, okay? On a mechanical setting, I'm hoping that you all can see the little silver dots that are on the trunk there. There's actually 6 of those silver dots. Only 3 are in the slide here. You can see one on the left at that bulge, and then down a little bit, one on the right towards the center of the tree, and above that one, there's another one. But there's actually, from the other side, there are rods that come through that tree because that's a codominant trunk formation. And if that right-hand trunk on the slide on the left, if that was to separate, it would catch the 2 houses there because the side limbs would catch it. That tree was rotted, and above it, if you look on the left-hand slide, way up in the top, 2/3 of the height from the crotch, from the weak crotch to the very tippy top of the tree, there's 3 cables in that tree that are helping to support the rods. The rods are there to solidify, if you will, the codominant formation of that sugar maple twin forks. The cables are up there to take the strain off of the crotch and off of the rods. All of this work that is done now on trees is guided, if you will, by ANSI 300 standards, which is American National Institute of Standards, American National Standards Institute. ANSI 300 covers arboricultural work. And there's 9 separate ANSI standards now that go from pruning, water management, fertilization, construction, and tree maintenance. There's 9 of them, and can't think of all 9 right off the top of my head, but rotting and cabling for safety's sake is part of this also, part of the ANSI standards. And if you all have, it wouldn't hurt to have all 9 of the standards in your office, because those are the guidelines. They're not etched in concrete. They are only guidelines, and they dictate and give guidance to the size of rod that should be put in, size of cable that should be put in, things of that nature. And it's very important when work is being done that those guidelines are used, because they're the standards. Years ago, when I started doing this work, we had 0 guidance, 0 things to look at to give us, we'll say, direction. Pruning was one of the major ways that bad communications was accomplished. Now we've got 4 major classifications of pruning. You've got a reduction, which dictates, we'll say, how the cuts are to be made, and you've also got elevation, and you've got a thinning guidance, and what's called a heading guidance. So there's 4 classifications, and using ANSI standards, if you look at the slide on the left, the standard pruning by a supervisor or a salesperson could say, I want the upper left quadrant from 10 o'clock to 9 o'clock reduced in length by 6 to 8 feet. It gives exact, we'll say, termination of how things can be done. So then the person doing the work has a clearer understanding of what is to be done along with the client, because it is so important that the client understands what is to be done to a mature tree for its stability. This tree is pruned every 2 or 3 years, and after every storm it's inspected. for further, we'll say, increase in the defects being in that crotch? Is there more? Pardon me. Is there more damage being done? I thought I turned that off. More damage being done to the crotch. Are there any broken limbs? Because you don't want this tree to fail, or even part of it to fail. Now here's restricted root system. This is at a governmental complex. And knowing the mature size, this is where proper planning at the time of drawings and acceptance of the drawings to the landscape division of the government that okayed these trees going in there. There's built-in obsolescence on these trees. These willow oaks, even though they're indigenous to the area, they put up with a lot of, we'll say, adverse situations, but they're not immune to restricted root system. You can see all the pavement surrounding these maturing. Actually, these are still immature willow oaks. They're only about 20 inches in diameter, but there's not enough root system to keep them alive. This is where the deadwood up in the tops of these trees is going to be rotting away. And it is going to become hazardous to the structure, to the target, which is a movable vehicle down underneath. These trees, in my estimation, should be removed. There's no sense in putting money into pruning them every couple of years, because there's just not enough room for the root system. Okay. Here's a no-brainer. The tree on the left, this is on a public road in the city of Richmond. That has been dying for a number of years, and that's evidenced by the amount of deadwood in the top. And it can be a combination of road salts that are put down, herbicides that are put on the lawns, oil and gas from vehicles that are seeping into the root system, just creating an adverse situation for the roots of that tree. And it's unfortunate because it's very preventable. And these large trees that we're looking at in both these slides here have the eco services that really benefit us in the built environment by solar radiation reduction. This tree over the pavement here, if it had a full canopy, would be reducing ozone, because it only takes 1/10 of a degree on hot pavement with carbon monoxide to create ozone, a 1/10 of a degree in raised temperature of the roadway. Whereas when that tree was able to shade the roadway, you wouldn't have ozone produced there. That's also creating bodily injury and a personal property destruction by that deadwood. The tree on the right, you can see the brown patches. That's hypoxylin canker. That is a obligate parasite that lives on dead bark, dead twigs as a saprophyte, meaning when the tree is healthy, it survives on consuming deadwood. When that tree becomes water stressed, it changes to a pathogenic fungus, and it consumes the cambium, feeds on the cambium. That's why the brown patches are just underneath the bark, and when the bark dies, the cork cambium dies, then you see the actual disease. Coupled with that, that tree destroys the strength of the trunk. It's called a canker rot. When you see that, that tree is set for removal. You can see it on certain limbs too. If a limb is over pruned, too much of the foliage is taken off of a limb, the limb will die back because it doesn't have the transpirational pull to get the nutrients out. the tree will actually shunt that, will actually wall that dying limb off to stop the spread of rot to the trunk. And you'll see that on limbs also. If you see it just on a limb by itself, the tree doesn't need removal, just the limb does. Okay. All righty. Now, sudden changes. It's the perpetuation of constant repetitive actions that cause the death of roots and or tops of trees correspondingly, such as happening here, because this is at a rest area and this ditch could have caused it. Herbicides put out here could have caused it. All sorts of things could have caused the repetitive actions that created the deadwood in the top and the beginning of the hypoxum canker. Another situation that we create in the built environment is the suddenness of our actions. The trees on the left of this house here are not wind firm because from the periphery in, the trees have been buffered by the exterior trees, okay? Consequently, they have not developed a very sturdy, stout root system, and they could also be root grafting with other trees. Genera to genera will root graft. These trees here at the front of this house are very prone to wind throw because they are not as wind firm as they should be. They're nothing but tall spikes. You can see that one on the left-hand side of the house there. All the foliage is on the windward side. Whenever you go to a property too, take a compass so you can locate the aspect and the prevailing winds. It's very helpful. The suddenness of our action coupled with the removal of the buffering plants along with the root damage that has been done by the grading, and that all the grading has been done by heavy equipment, and this is I term slash and burn building practices, whereas there are many ways of getting around this. And what fascinates me is these folks have paid 15% higher for this wooded lot. When the building is through, and we'll say it, at least after 1 year, they probably will not have half the trees that were on the lot that were left there, but they have to pay for the removal of the trees, and yet they're still paying the escalated price for the wooded lot. Tax-wise, they're still paying an inflated price of the wooded lot, which a year after construction is not a wooded lot. And there are ways to work around this. It's called low impact construction. It's very doable, and it's actually no more costly than is normal construction. Builders try to tell you, but I can verify that it's not any more costly. It's actually improves the property by the aesthetics and also the eco services that the trees that are left provide the house. One of the most important is reduced cooling costs by the shading. So low impact construction is not undoable. It's very cost effective. This is very abnormal weather conditions. This is from a tornado that touched down in Lancaster County about a month ago, in July sometime. This is what's left after the tornado went through, and they said it was winds of 150 miles per hour. It's really hard to believe the decimation that is caused by the abnormal weather conditions. This is fringe after this is the property that owned the destroyed woodlot there. This big tree in the front here is a hackberry. The only thing I would do on that tree right now is take out the broken and the weakened, we'll say partially failed which means that they have a fissure in them and they have a break, and you can tell that because of the cambium is distorted. And if you look closely, you'll see that the cambium in certain limbs has got a horizontal line. That is a almost failure. It's not it's an incomplete failure is the proper term. If you take that limb out or prune it back and take out any hanging wood, any you can see on the left there between the magnolia and that is a magnolia in the center. Uh, you'll be surprised. Just take that out and let the tree tell you where it's going to die back to, if it even does die back. We'll pick on the magnolia in the center there. You can see the hanging branches and the spike up in the air. I would just cut those down, take out the broken pieces, the damaged areas, and I wouldn't even cut the damaged areas all the way down. I would just cut it and let the tree come back by itself. Mainly from the standpoint, these are two old historic trees on the property. And if you take it out right now, of course, the tree is gone. You give it half a chance, because the clear white wood that you see on that spike and at the broken areas, that clear white wood is stored energy. The plant has the ability to rejuvenate and to put out new growth. And every couple of years, you can take out some of the weaker unions. So after about 5-6 years, you'll still have the plant there, and you'll be pruning it every couple of years to take out the weak regrowth. It doesn't need to be removed immediately. And if you were even just to stump cut that right now, that magnolias come back readily off of stumps. And you can nurse that in such a way that you'll get a good growing, sturdy single trunk coming off of that stump. Okay, this is on the far left is a small hackberry, and that could be pruned back a little bit because that upper limb on the left-hand side there, about 10 o'clock high, that would be termed overreaching limb. That could be cut back a little bit, and it doesn't take much, and you tighten up the entire beam that you're working on. Pruning is such a therapeutic way to prevent a damage. For the sake of argument, if you have a 100-foot lever and you reduce it by 1 foot in length, you take it down to 99 feet, you've taken 100 foot-pounds of torque off of that lever. Okay, so it doesn't take an awful lot of pruning to get a big result. Okay, tree risk assessment considerations. Okay, again, I have to emphasize this over again, is for normal loading conditions. Okay, extreme winds over 60 miles an hour. And another thing I need to make mention of is downdrafts and wind shears. Those are very localized. I mean, just a couple blocks or just within 100 yards, square 100 yards, where sudden wind changes due to precipitation creates a wind shear, a horizontal or a downdraft caused by the sudden change of temperature because of the precipitation. Okay, look at the whole or look at parts of the plant and start your visual tree inspection from a distance where you can look at the whole periphery. And if it's been exceptionally wet, look for soil failure, which would be heaving on the uphill side and a depression on the downhill side. If you see any of those two situations at the collar, that is a prime suspect for failure, total upheaval. Okay, mitigation situations you can mitigate things with removal of the target if it's mobile, or pruning and support parts or all of the tree. Okay, important tree risk assessment. Because mature trees provide so many eco services, we need to perpetuate them, and a lot of it begins at proper installation and handling at the nursery and handling at installation, because they're solar radiation reduction, stormwater mitigation, pollution absorption, and also particulate matter is so important. And aesthetics, we can't underestimate the amount of aesthetics and carbon sequestering for the climate change. Okay. Master gardener roles are able to recognize the potential conditions and advise the owner on the situation. Okay, you'd be surprised at how clueless people are when it comes to woody plants, because they get erroneous information from all places, and it's up to the owner to seek the management of remedies. It's not up to you. Okay, you need to inform them about hiring consult a qualified certified arborist for appropriate mitigation and for remedies. Okay, now goodtreecare.com is one of the major ways that we in Central Virginia here can locate qualified people. That's through MAC ISA, Mid-Atlantic Chapter of International Society of Arborists. And you just type in your county, and then they'll give you the qualified people in your county or in your area. Another good way is that most offices, extension offices, keep a list of qualified arborists. And also you can contact me, and I'd be happy to supply you with information of folks in your area. Okay. And I hope I've left a couple minutes for questions. Any questions?
Yes, thank you so much, Joel. That was a lot of really good information, and hopefully everybody learned a couple things. We do have a few questions that have come in, so I'll start going through those and we can get through as many.
Okay.
The first is, do you prune when damage occurs or wait until dormancy to minimize fungal risks? And then on the same question, when do you recommend treating pruning wounds with a sealant?
Never with the sealant. Okay. That got started in orchard work where they would bud and graft, and they would use paraffin, which would break down, biologically would break down. The sealant that you get now, I've peeled it off of trees, trunks and whatnot, and termites come flying out of there. It really doesn't do any good. Trees have been around a lot longer than a tree coat has, and by their own ability to compartmentalize, it's called CODIT, compartmentalization of decay in trees. Getting back to the pruning, I would actually, there's no need to really prune immediately. Okay, we used to think it was beneficial, but I would let the tree start forming barriers, because within hours, the tree chemically, by the damage created, the tree has received signals that there's a damaged area. It will send nutrients to that area, allow the tree to start setting barriers and boundaries, and then prune outside that boundary. And you'll tell the boundary by the cambial growth around it, if that makes sense. Does that make sense? We have to stop thinking for the tree and let the tree show us. Okay, because the tree is actually smarter than we are.
That is good advice. All right, we had a question about plunger planting. Could you go through what you mean by that?
Oh, I'm sorry. Okay. Envision a plumber's helper, a plunger that you use in a commode, okay? Because you could see how the trunk was coming up, that's the handle, and then the arc or the concave configuration of soil. It's where in the built environment, the soil is so compacted. People dig a nominal hole, they just big enough to put the ball in. And then the soil that is excavated, they put on top of it, forming that dome. Okay, does that explain it?
I think it does. Thank you.
Okay.
Could you explain what exactly happens inside the tree when there is root girdling?
The girdle, it's like you putting a tourniquet on someone's arm, on a youngster's arm, we'll say, a 5-year-old, and expecting the growth of the limb to increase symmetrically above and below the tourniquet. There is a reduced flow in our vascular system that would impede the growth below the tourniquet. That's what happens on a girdling root. The nutrients from the root system cannot go past the girdle created by the roots. The sugars coming down from the top of the tree cannot go past that. You actually get a flange created where you have an enlargement. You can see in the slide on the right and left, you can see an enlargement on the aerial part of the plant right at the girdle there. It's flanging out. That's where the sugars can't make it to the root system, causing the root system to die out because it's not getting the energy. That red bud in the slides lived on its stored energy that it had in its wood, because wood is stored sugar. It had in the wood, it lived off of that, if you will. It lived off its fat for a few years. Okay, does that make it clear as mud?
Yes, thanks. I think that was good information. So kind of connected to those tree issues, could you explain what dieback is and how to identify that in a tree?
Okay. When a root system is, let's see here. When a root system doesn't have the surface area to absorb enough water and minerals to satisfy the top's requirement, the lower branches, because keep in mind by transpirational pull, the lower branches get all the nutrients first. The dieback in the top of that slide, on both those slides, is because there isn't enough to go around. So then the extremity dies out first. And you can see on both of these slides, these lower limbs right at the extremity, that dieback is at the extremities on the vertical and on that horizontal limb. That's because there wasn't enough to go around, so those closest to the source get it first.
Great. Okay, we are a little after 11, but we're still getting some questions in. So this is recorded if anybody needs to leave.
I'm fine with that.
Okay. So maybe just a few more questions and then we'll end. Does that work?
Like you got the controls.
All right. So we'll just go through maybe 2 or 3 more questions.
Okay, sure.
Could you talk about the impact of mycorrhizal fungi on tree health and growth? And if there's anything that homeowners or landowners can do to help?
My master's work was on mycorrhizal, and it is a phenomenal fungus that increases the absorptive potential of root systems for water and primarily phosphorus. Phosphorus is one of the most important elements for energy because it goes in, it is very important in our respiration and our breakdown of sugars for energy. The phosphorus that is absorbed by the plant through mycorrhizal benefit is, they say, 700-fold. You increase the health of the plant by the increase in phosphorus and in water, because water is generally in our built environment the limiting factor. To perpetuate mycorrhiza in the soil, you need to increase the oxygen and the structure of the soil by increasing the oxygen, because mycorrhizal is fungus, it needs the oxygen to survive. By increasing the water and the nitrogen, you increase the ability of mycorrhiza to initiate growth in the soil and perpetuate itself in the soil. Over nitrogen fertilization will reduce mycorrhiza in the soil. Overwatering, because it will drown out the fungus, will reduce the amount of mycorrhiza in the soil. Proper air and mixture is the most important key, because it builds the structure of the soil, which in turn builds the mycorrhiza population.
Great, thank you.
Okay.
I think our last question for the session is, if someone was interested on more information about low impact construction techniques, where would they be able to find information about that?
I don't know of any publications, but that's a good, tell them to contact me, and I could just ask them to contact me, and I could give them some pointers.
Okay.
I've got 3 or 4 properties in this area in Central Virginia that we did it. We did low impact, and the people tickled pink. They're over 20 years old and still have all the trees, and they're paying, how can I put it? They're gaining in the eco services that the mature trees are providing for their structure.
Thank you very much. So I think with that, that is the end of our presentation. I am putting an evaluation into the chat box. And this is for Joel's presentation. So if you have a minute, please fill that out. And then Joel, if I'm correct, your email is at the bottom of that document, and they can email.
I think, yes. It's Perfect. Also on the last slide. I can go back to that very quickly. Oops, there we go. It's real simple, jkoci@vsu.edu.
Perfect. All right, well, thank you so much for joining us, Joel. This was a fantastic presentation. We've had a lot of comments in the chat box that people really enjoyed it and got a lot of information. So we so appreciate you joining us this morning.
Thanks for having me, Miss Reed, and you guys all take care. And if you have any questions, just don't hesitate to contact me, please. Okay?
Thanks
That's what I'm here for. Thank you. Thanks a lot. You all have a good day and stay well.
You too.
Bye-bye.